Okay, so here we are. We are starting with objects today. Hopefully, I'll get through all of them. There's 11 exercises. If not, I'll make it a two-parter. We'll see what happens. Here's the link for you, and let's get into exercise 1. So, given the following code, how can you access the name of the person? All right, so you can use dot notation or bracket notation for this. I'll show you both of them real quick. Um, So if we have this person variable assigned to the object that has those properties, object literal actually, um, we can do console log, and let's do person. So we can do person.name, right? Because we want to access the name, or we can do um, no, bracket notation, and I believe we have to do this. Make it a string. Yes. So if we didn't make it a string, it would be looking for a name variable, um, which could have the value, could evaluate to a string, which is a property name. But in this case, we just want the name property name. And all property names of objects are actually strings. So even though they're not written as a string here, they actually are coerced into a string. And so this should return two bobs. And let's see if it does. This. I didn't test this beforehand. Hang on a second. Okay, so this should work now. So there we go. We got two bobs down here. One bob, two bob. So yes, so that works fine. So let's check the answer real quick and see. Yeah, so it's just the two things there. So exercise 2, which of the following values are valid keys for an object? Well, we have the string 1, or we have 1, the number 1. You know what? I'm gonna delete this. Kind of hard to see with the backticks. All right. So we have the number 1, we have the string 1, we have undefined, we have the string hello world, we have true, and we have the string true. So this is actually not a boolean, it's just a string. So 3 strings. So the question is, can we use strings as um, valid keys? And the answer is yes. And can we use numbers as valid keys? And the answer again is yes. And what about undefined and boolean? So boolean yes and undefined yes. We can actually, all of these can be valid keys. Now what JavaScript's going to do for anything that's not a string is convert it into a string, or coerce it into a string. So it implicitly is going to coerce this true into this true, and then it'll coerce this into the string undefined, and this will be a string of 1. So yes. So all of them non-string keys are coerced into strings. Perfect. All right. Use object literal syntax. Okay. To create an object that behaves as an array in a for statement. Right. The object should contain at least 3 elements. You should place your code between the braces. Okay. So let's do that. And we want to put our code here. And okay, so the for statement's going to loop over this as as if it's an array, but it's actually an object. So I think we can just do like this, because that's going to do the string 1. Wait, actually we want to start with 0, string 0, and we want it to be able to tell the length of the array. My array dot length. So it's going to need a length property. That's going to be 3. Um, what is, let's see. Okay, so I guess it doesn't really matter what the value is. So we'll just put the same value. Yeah, wait, why am I doing this? Should be a comma, and then 1, 1, 2, 2. All right, so that should mimic an array, because essentially this is what an array would have, although, these values could be anything. They don't have to be 0, 1, and 2. Actually, why don't we just make it 1, 2, and 3? Yeah, there we go. So when we run this, it should log 1, 2, and 3. So it should cycle through there and log that. Let's check it out. There it is. So 1, 2, 3 right there. So that's good. Yeah. So that is essentially the same thing as if we had an array. That basically is what arrays are. I think there's some other differences as well, but essentially this. So let's check the answer here. And yes, that is almost that is exactly the same answer that I have. That's interesting. Okay. Create an array from the keys of the object obj below with all of the keys converted to uppercase. Your implementation must not mutate object. Okay. Order of the array does not matter. All right. All right. So we have this object, and then we have to um, return a new. Looks like. Create an array. So we have to return an array of keys, all uppercase, and the order doesn't matter. Okay. So I feel like there's a few ways to do this, but like one of them would be to let's see, to do object dot keys. So this is going to give us the keys map, and then key to uppercase, and then that should do it. So that should return a new array um, of all the keys uppercase. Let's see if that works. No, something didn't work. Cannot read property. Huh? Oh, maybe it's this. Oh, stop it. Object dot keys. No, object dot oh yeah, no, dot keys, and then object. Let's try that. Is it that? Yeah. Sorry. Uh, keys is a property, is a method on the object, on the base object, not on. It's not a method, I guess, that all object literals have access to. Anyway, so yeah, there is one way to do it. That is each key converted to uppercase. So yeah, there's another way to do it. Obviously, we could get the keys, cycle through the keys, and then that's basically what we did here. We get the keys, and then we iterate over the keys and convert each key to uppercase. I'm using arrow function, but definitely possible to do with a for loop if we wanted to do that, which I'm sure the answer is going to have of a for loop. Let's just do it as a for loop just to do it. So I might have something like let keys equals object dot keys object, right? And then uh, I would probably want to have let array equals that an empty array. Um, and then do we want to do a for each or just for? Let's just do a for loop. So for let index equal 0, um, index is less than or equal to um, object length, no, not object length, keys length, and then index plus equal 1. All right, so that's our for loop, and we're expected an expression here. So what do we have? For loop. Then inside here, we just need to push array dot push um, keys index. Keep doing that. Okay. And then down here, we just need to console log array. And so that should also, so this grouping of code here from lines 9 to 16 should also, yeah, should also give us the same result. Let's see. No, it did not. What did we do wrong here? Oh, first of all, we forgot to. Okay, so one time we're a little bit off. I forgot about the length. The length is one more than the available index, and then also we forgot to upper to uppercase the call to uppercase on the value to actually make it uppercase. So there we go. So yeah, the length is in this is going to be 3, but when you do the find the indexes, it's 0, 1, and 2. So if I go up to 3 and including 3, I'm going to have a third index, which if you try to access an element of an array that doesn't exist, then you'll get undefined. Undefined is returned. So that is what happened there. And let's go ahead and look at this. All right. So this one uses the answer uses for each, and then upper keys. So yeah. Oh, using for each. What is this? And then this is the first way that I did it last time I did this. So there you go. Oh, and then of course we need to do this to show that it hasn't changed. And you can see that the original object has not changed at all. Um, so there you go. All right, create a new object named myObject that uses my proto-obj as its prototype. Prototype. I totally forget how to do this. Let's see if I can remember. We need to, I think we're gonna do let my object, hang on, let me check this out. I totally forget how to do this. Okay, so it actually is object.create. And then I think what you do is you put my proto object in parentheses here, and then my object should then be have the same properties as, or should inherit from my proto obj. Something is expected. Missing semicolon. Got the semicolon right there. Well, let's see. I don't know if that's gonna work. No, it didn't work. Yeah, it didn't. It's oh, you know what? Object dot create. Hang on. Maybe I missed something. Okay. Well, it's good thing I went through this because I am not thinking clearly. Object. There we go. So yeah, it's another one of those. It needs to be called on the object class, I guess. I don't know what this is called. Prototype. So my object, my obj will. You can create a new object with this as the prototype. So even though we haven't added any properties to my object, it should show them. I think. Maybe not. Maybe I don't know. Let's try this and see what happens. Okay, so yeah, no, it's empty. But if we were to access foo here, we would get 1 down here. So yeah, so yeah, and same thing with bar. So even though there's nothing in it, we actually can access the values, the keys and values from the prototype. So let's see if that's close to the answer. Yep. So there's your answer right there. Good. All right. And all right. So let's do which of the following values are primitive values, which are objects, which are neither. Okay, so let's go ahead and I guess we'll just, I don't know, let's just go through each one. So again, I am going to, I think I'm gonna, um, I'm gonna erase all of these. Okay, so um, let's do that. There we go. Good. So foo, the string foo, is that a primitive or is it an object? So that is a primitive. This is a number, so it's a primitive. This is an object. This whole thing, it's an array. Arrays are objects. This is a primitive Boolean. Um, I guess this would be a variable name technically, because it's not a string. Um, so variable name is, I don't think it's either. It's not an object or a value. This one's neither. Function. Function is an functions objects. I think I think function I think function is an object. Um, the first class functions are first class functions in JavaScript, so they can be passed around and everything. So I am guessing object. Undefined is a primitive, and this object is an object. This is object literal, so it's an object. Let's see if I was right. So primitive, primitive, object, primitive, neither, object, primitive, and object. Yeah, good. So there you have it. Yeah, so understanding primitives is important because primitives are cannot be mutated, and so when you need to um, change, let's say we wanted to change foo to a different, like change one of these characters in foo, we're actually not going to be able to do that. We have to create a whole new primitive string with the value that we want instead. So just knowing that is helpful. Whereas if we wanted to change one of these elements in this array, that's possible to do. Um, so that's why we asked this question. All right. Add a QUX property with value 3 to the myObject object we created in the previous exercise. Okay, so I put this here to help. Good. Oh, actually, I still have it on the screen over there. So we want to add a property. Wait. Now examine the following code snippets. Oh, okay, okay. So we want to do myObject dot QUX equals 3. Okay, so we've added QUX property to myObject, myObj, obj. So now examine the following code snippets. Without running this code, can you determine whether these two snippets produce the same output and why? All right, so let's look at this. So we're getting the keys of my object. All right, so now this is, are we getting all of the keys or are we only getting some of the keys? Um, I really don't remember if object keys, I think, okay, let's see. And then this one, we're using a for in loop. Okay, so I think in this case, we are only getting the one key that we just created. So it's going to be QUX is going to be the key that's going to get returned, I think. And then in this case, we're going to get all of the keys. We're going to get foo bar and QUX. And the reason for that is because I think when you do a for in loop to cycle through the keys, you actually get all of the keys in the prototype as well. And you have to test for that. And it's possible they both do that. I cannot remember. So let's look at the answer here. And because I think there's some more to this. So there we go, we added it. They will not return the same output. Snippet 2 will return the keys from my object and the prototype of my object, while snippet 1 will only return the keys defined directly on the my object. Using has own property, right? That's the key there. We can make snippet 2 only return keys that were defined directly on the my object. So yeah, so this one's going to return all the keys in the prototype and in the current object, and then this one's only going to do the my object keys. And so this could be how you do it. If my object has own property key, console log the key. If it doesn't, if it's not the property with that was defined within this particular object right here, then do not log the key. So this cycles through all the keys, including the prototype. Okay, so yes. I don't know why it does that. It just does it. All right, exercise 8. Create a function that creates and returns a copy of an object. The function should take 2 arguments, the object to copy and an array of the keys that you want to copy. Do not mutate the original object. The function should let you omit the array of keys argument when calling the function. If you do omit the argument, the function should copy all of the existing keys from the object. Here are some examples for reference. You know what? Actually, I am thinking that this might be a good place to stop and start over another recording. No, let's just finish this one, and I'll stop maybe after this one. All right. So we have this new object. We want a copy object, object to copy, and we have new object. Okay, so let's put in between here. So copy object. We could just call it object. All right, so it takes one. Actually, it can take 2. I'm gonna use, I think, a default. What are we calling this? Keys to omit. Key, no, an object, a copy, and an array of the keys that you want to copy. Keys to copy. There we go. Right. And then we want to I feel like I could do this with a filter statement, but let's just do this. So we have keys to copy. So the first example down here, you'll see that we have all the keys. So let's just do that first. So we want to return all of the keys of the object. So I think, well, I guess, yeah, return object dot keys object. No, actually, that's not what we want. I think that will do it. But it has to be a different one. Do not mutate the original object. Oh, okay, right. That's not going to be a copy of the object. That's going to be the same type of object. There is a way to make a copy of an object. Hang on, let me check that. I know how to. Okay, I think I know how to do this. So, all right. So we have to have a new object. So I'm just going to call it new. Let new object equal empty object. And then I'm going to say it doesn't say anything about a or the key in object. So for key in object, we want new object to be key equals object equals the value of key there. And so that should then we return new object. So that should work right there. So that will go through all the keys, and then it should give us the key and the value, put it into this new object, and then we return the new object, and they should be different objects. So let's say we were going to do keys to copy. So now we're going to have to I think we just do an if statement here. If key, no, keys to copy dot include, right? It's going to be, yeah, includes key, then, shoot, this is probably going to be, there we go. Oop. Okay, that'll work. All right, so if keys to copy includes key, then I guess we should probably check if keys to copy is not empty also. So if keys to copy length is greater than 0, and all right, so if it's less than 0, we're just going to go ahead and not try to wait. No, want to. Yeah, so the problem is this won't run if it's not greater than 0. So if keys to copy, oh, you know what I could do? I can make this equals object object dot keys object dot length. So either it will actually, so then I don't think I need this keys to copy. Oh no, that's not gonna work. Okay, so that might work. So we could just make it equal to the keys that are in object, right? And then if I don't think we need any of this here, right? So what we're doing here is if we can, if keys to copy doesn't have anything, if nothing gets passed in as that argument, if we don't pass any array as an argument there, we'll go ahead and set it to the object's keys, and then that way, basically it'll do every key because every key is going to be in there. So that should work. Let's test it out and see what I messed up. If I messed up anything. So foobar QUX is 3, and then oh, interesting. I wonder if I have these wrong in this example. Oh wait, no, sorry. Foo, okay, and bar. So yeah, everything got right. So that is at least one way to do this. You can use, I think there's another way to do it. Like we could probably cycle through the keys using for each or something like that. Doesn't really matter. So let's see what other ways to do it, or whatever I have here in the answer. So if keys, okay, so we just called it keys. So if keys, return keys dot reduce. Wow, seems complicated for this. Accumulator, current, and then we go through each key. We do the same thing here, and then we kind of build the object up there, and we start with an empty object. Okay, that's one way to do that. Otherwise, object.assign. Assign's a tricky way to do it. I like that. But not necessary in this case. Okay, so that's one way to do it. Do I have another way to do that? No. That's the way that I chose to put up there. I think I'm going to actually put this other way to do it too. Okay. So let's add that in here. oops, answer 2, and we'll surround this in backticks. So yeah, we'll just add that in there, and there we go. So that's answer 2. Answer 2. Actually, we'll just do that. I should probably put this here. Okay. All right, it will go away later. So that was 8, I think. We only have 3 more to do, but I have a feeling they're gonna get possibly harder. Um, let's push through and see what we can do here. What does the following program log to the console and why? All right, so we have an object here. We have a variable here assigned to a string, literal. We have a function that takes 2 arguments. One of them, we're going to get the property, the A property of it, or method. We're going to set that to high, and then the other one we're just going to set the argument itself to high, the string high. Bar. So now we're calling this function bar, and we're passing in foo and qux. So we're passing in the object, and we're passing in qux. Okay. And then console log foo a is what, and what is qux? Okay, so in the case of this variable here, because we declared it in an outer scope, in the outermost scope, it's available within all block and function scopes, inner block and function scopes. So we have, we can access it here, although we don't even need to because we passed it in. So argument 2 then references the string hello. Unfortunately, because we did it, well, yeah, I think because we did it that way, it's actually not going to be accessible outside of this function, because now we have argument 2 variable that's referencing another string literal hello. So now it's referencing another string literal hi. So the answer down here is going to be hello, because it has not changed. So this change does not change anything for the string. For the object, it looks like we are passing the object. Now with objects, when you pass in an object, it's actually passed by reference. So this argument 1 variable in here, argument 1, is going to reference the object up here. And so it references that actual object in memory. It will actually change that object. And so the A property will be, or the A key will have a value of high, the string high. So down here, we're going to see high, because it actually does change this object. And here we're going to see hello. So let's just check the answer. I'm not going to run it. So hi, hello. There you go. So this is about saying that objects are mutable while strings and other primitives are not. It also demonstrates that variable reassignment does not mutate the original object even if the object is mutable. Demonstrates that variable reassignment does not mutate the original object even if the object is mutable. That doesn't sound right. Variable reassignment. This does not mutate the original object. I'm not sure if that's right. That doesn't sound right to me. Within the function bar, we reassign the property when we reassign the QX variable. All right. So there's a lot of words there. You can read it if you want to pause it. But I'm going to move on. So basically, yeah, this argument 2 is shadowing right here. Is shadowing, actually it's not shadowing. It's just a primitive. I think it's actually shadowing and it's a primitive. So even if it wasn't, well, if it wasn't shadowing and we were here, let's try it actually. I'm just do this real quick. I just thought of a new All right, so let's say we want to change it here equals I. So now when we do this, it should actually change because you can actually access. So this would demonstrate variable scope and how if since it's in the outer scope. Da, da, da. So this argument 2 is something else entirely, whereas here we're going to be accessing the same QUX variable here, and it should. So now the result should be high high. So let's see. So there you go. You can see it down here. High high. So yeah. So this I don't know if I would call it shadowing, I guess because it's not the same name, but it essentially it's just a different variable pointing at a different string literal. That's it. Um, so and then this is going to be shadow. This is not shadowing. And then if we wanted to shadow, well, we would probably do something like this. Right. So now, um, so I don't know why it's saying. So now when we try to change it, this should not change, and this should be back to hello again. So let's see, it should be hi hello again. Yep, because we have now shadowed the variable. So when we're reassigning this string here, we're actually reassigning this QUX variable, not the QUX variable in the global scope. So because they have function or block scope, actually block scope, I think. So yeah, so that's that. Let's see what we can do. How many primitive values are there in the following expression? Identify them. How many objects are there in the expression? Identify those objects. All right, so primitives, we have 1, 2, 3, 4, 5, 6. 6 primitives, it looks like. And then we have one object, two objects, 3 objects, and 4 objects. So 6 primitives and 4 objects. Yep. Good. So there they are. All right. And last one, write some code to replace the value 6 in the following object with 606. You don't have to search the object, just write an assignment that replaces 6. Okay. So we want to write object dot bar. So the 6 is kind of nested deep inside here. So we just have to figure out how to get access to that. So we're going to do object dot bar. So now we have an array. So 0, 1, 2, so 3. The third element of that array, and then we want the XYZ value of it. So actually, let's surround this in console log, and that should return 6 for us. There it is. 6 right there. So this is just an example of kind of accessing a deeply nested, maybe you have like JSON and you're trying to get access to this particular value for some reason. And so yeah, sometimes you have to go through a lot of different things to get to it. I think there's probably a better way to do it if it was, I don't know, but this works. Let's check the answer real quick, right quick here, and that is, oh, we were supposed to get 606. Wait a minute. Oh wait, I did the wrong thing. To replace the value, ah, yeah. So that gives us, all right. So we want to replace the value. Um, Equals 606, and then that should work. There we go. I think I did that the first time I did this problem too. So that's the way we did it here, and then the other way is to use bracket notation, which actually might be a little bit easier to read in this case, just because it's showing the nestedness of it. So there you go. All right, great. Hopefully that helps. Definitely helped me because I am a little bit rusty and I'm going to be taking the test soon. So, thanks for watching.